Okay, Eric brought this to my attention, this one particular video. It's hilarious what the convex tards will assume or want to believe so badly that there's some type of aliens out there in outer space. No, no, mind you, but it's hilarious. So they're trying to attach this. They're realizing that there are echoes. They're detecting echoes with radio waves, and I'll play a little part of the video here.
Of 1974, a man by the name of Duncan Lunan published an article called Space Probe from Epsilon Bootis. It concerned a mystery surrounding long-delayed radio echoes, or LDEs, first reported in the 1920s. Mysterious echoes of the transmit...
Long-delayed radio echoes. Oh, yeah, they got a fake convex Earth here.
Voice, which were far too...
What are they bouncing off of? Well, why are they returning? Interesting. Well, we know that you need a specular coherent surface to reflect those radio waves.
Powerful to
a hard surface, as in glass, right?
Been simple reflections from Earth. Experimenters studying all over the world found that their outgoing pulses were being returned to them with a delay of 3 seconds, as if they were being amplified and returned by something at the distance of the moon, but definitely not the moon itself.
Not quite that distance. The moon is a little bit higher, but it's behind its own negative refractive glass. But I think we're talking about the 100-kilometer glass here, and interesting how they try to stretch it. You know, this is a subjective conclusion. It must be like connected with this particular constellation. It's hilarious.
Delay times began to vary upwards from 3 seconds in increasingly complicated sequences, but with no variation in intensity, still indicating a single source amplifying and returning the pulses.
A single source?
Professor Ron Bracewell.
Source in time. That means you can transmit a radio wave at any particular location within my concave Earth, and the time difference will match up. Yeah.
Stanford suggested in 1960 that the echoes might have been rebroadcast by an unmanned probe from another civilization. Attempting to get our attention.
A craft.
And in 1972, Duncan would make an incredible discovery, successfully making a translation of the echo patterns. The variations of delay times appeared random, but Professor Bracewell himself had suggested that if indeed a probe, the first signal might be a starman.
It might be a starman.
After plotting the delay times in chronological order, he found what indeed looked like a starman.
No way, really?
Upon showing this to astronomers, it was recognized...
What astronomers? Or can they list their names?
...to have been a warped image of Epsilon Bootis.
A warped image of Epsilon. So that's why they call it Epsilon Bootis. It's a warped, and they're stretching it, right?
In the constellation Bootis, Arcturus, the brightest star in the constellation, seemed to be out of place in the map.
I wonder why it was out of place. Maybe because it wasn't a star map. It was something that you were just trying to stretch to fit, but you couldn't do it. And so that's, here's an illustration I made earlier of a radio signal being transmitted, and it's hitting the glass sky, or the glass/ice sky, and it's returning specular coherent reflection. That's how we bounce back radio signals, because we have a hard glass/ice surface at 100 kilometers, and it's creating the reflection and the echo. You smart guys will understand. Okay, bye-bye. This is a follow-up video to the one I just made previously about the echoes that they are detecting with radio waves, or they have been detecting probably since 1920 or something like that. But it fits perfectly with the understanding that you're inside the concavity of my Earth, and there are glass concentric spheres above you. There is a glass concentric sphere covering the sun and planets, which is closest toward the celestial sphere in the center. And then there is a negative refractive moon glass sphere that's covering the moon. And then there's the 100-kilometer glass sphere. But keep in mind, now, these echoes that they are detecting, they say they roughly the rate in which they're detecting them is roughly around 3 seconds. And so that's also with the understanding, needed to understand that you don't know how much light is slowing down the closer you get toward the center. If you go into Wiki, just simply search slow light. They have many different ways, many different mechanisms which you can generate slow light, and especially because at the center of the Earth there's that magnetic octahedron along with the primer field tree of life. That's the center. And so there's ways in which they can slow the light down. There's electromagnetically induced transparency, EIT, coherent population oscillation. Not really. I mean, you can look into the details of how they explain them. Four-wave mixing, that's another interesting one. But keep in mind there are so many ways. I mean, light is not a constant. There's so many. Even Richard Cohen, the ex-NASA mathematician and scientist, who did find mathematically he resolved concave Earth, and before I ended communication with him, he let me know that yeah, it works, but the light speeds up toward the equator, and so there's variation in the velocity of light. It's simple. It's simple Einstein. And so single negative metamaterials or double negative metamaterials, that's interesting too, because it has to do with the phase conjugation or the wave coherence that I would talk about that envelops the moon sphere and that creates a negative refraction. And so because we're getting these echoes, that fits perfectly with the understanding of it hitting a phase conjugate wave coherent, and it's returning back that, just like if you look up in Google, phase conjugation mirrors, and that's what we're getting. Like there's another one here. This one here, that's a good example of it. So we're getting this on the right side. You see the phase conjugate mirror, and so the light ray is returning the exact same route it made to hit that reflective surface, instead of a conventional mirror where the light ray just gets reflected out like that, and the angle of incidence is the same as the angle of reflectance like that. But in this case, that's what's going on with the phase conjugation happening, and that's why we're getting that echo, because it's a phase conjugation, right? It's negative refraction. It's bending. It's creating the moon to look more flat than it actually is because of that.
Indicates.
Shh, Steve, quiet. Because of that negative refraction, the phase conjugation that's happening like that. And so, like I mentioned before many times, the moon's apogee is actually its perigee, and vice versa. It creates a thinner crescent when it's closer toward the sun because of that negative refraction as well. And so there's many good reasons to understand that. Actually, reason to understand that as it appears to be bigger, it's actually farther away from Earth, but it's going faster. I mean, it's closer toward the center primer tree of life. So it's increasing in velocity like that. It's being more in sync with the celestial sphere, sidereal time. So that's what is happening with that. And so that's proof positive. There's a phase conjugate glass mirrored reflection that's creating the echo and keeping in mind and understanding that light slows down once it gets toward the center. You understand? Perfectly. Okay. Ciao, I love you, creation.